This is Kyle Thompson performing the control data test for the main control unit of the Raspberry Pi of the large-scale Tetris clone project. So the first step is to connect the control data connection to a test PC using its COM port, and this PC needs to be booted into a Windows operating system. So here I have the Raspberry Pi connected to a Max 3232 breakout board, which is then connected to a female DB9 connector in the back of my test PC. And this test PC is running Windows XP. So the next step is to connect an HDMI ready display to the Raspberry Pi. The Raspberry Pi has already been set up and booted for this case, so it's connected to this HDMI display over here. The next step is to set up HyperTerminal on the Windows machine to use the connected COM port at 115.2K baud, 8 bits per word, no parity, 1 stop bit, no hardware flow control. So I'm going to go through the process of setting up a new connection. Let's just call this I'm going to call it test. And then setting it up to COM1, which is what it was connected to. And then I'm setting up the bits per second to be 115.2 kilobaud, 8 data bits, no parity, 1 stop bit, and I'm turning off hardware flow control. Apply, okay. So now we're in a HyperTerminal session. Power up the Raspberry Pi and open the interactive Python terminal as root. This has already been done, but I can show you in the terminal where I have done this. So at the very top I have a sudo Python, which got me into the interactive Python interpreter, and I ran through a script here which I wrote. So it starts off with from serial import serial, and what that is it's from a module called PySerial, which allows for interaction with a computer's serial ports. So I have from serial import serial, then I create a serial port when it says ser is equal to serial, where the port is equal to dev, so in the devices folder dev slash ttyama0, which is the UART that I'm using on the Raspberry Pi, with a baud rate of 115,200. The other options are standard for it, so no hardware flow control, 1 stop bit, and 8 bits per word. And then I called serial.open. Now just to confirm that this was open, it raised an exception where it says port is already open. So the next step here is I just created a string that's 512 bits long, and it's basically just counting up to from 0 to 63, so it's 64 groups, and each of these groups is 8 bytes. So together this is 512 bytes long. The next step is to type ser.read in the Raspberry Pi terminal window. Now what this is going to do is it's going to set it up so it's expecting to read 512 bytes, and it will block until it reads these 512 bytes. So I'm moving the keyboard input from my test PC to my Raspberry Pi. So now the keyboard is plugged in here, and I am typing ser.read. So now it's just hanging there because it's expecting to read 512 bytes. Now, because I only have one keyboard, I'm having to switch between using my keyboard for the Raspberry Pi and for my test PC. So if I can disconnect this real quick and put this in my test PC. My next step is to transfer a text file. So I've already written this control data text file. You can open it up real quick. But it's basically a 512 bytes of text that I wrote. So this goes on for a while, but we'll be able to see it better in the terminal once it's received on the other side. So I'm going to close out of that. And I'm going to select that to open. So now what this is going to do as soon as I open it is it's going to send the data from my terminal window to the Raspberry Pi. So keep in mind that there is only one USB device currently plugged into the Raspberry Pi, and that's the mouse. So I'm going to stand back just so that it's obvious that I'm not trying to type on the keyboard and use it at the same time. If I could figure it out. Okay, so I am hitting open. And then over here we have the same text file that was sent. So it looks like I accidentally added a new line at the beginning of the text file, and it cut off my last N on the senior design. So that means that it received all of the data correctly. I can verify that this is the correct data by reading off what the text file was and then comparing it. So I'm gonna look at this text file again. So it says this is a test of COM1 serial port. It will be used to test the control data signal, which transfers data using the RS-232 protocol at 115.2K baud rate. Just scroll over here. The Raspberry Pi will need to receive data using this connection, or need to periodically receive data using this connection. This is how it will read the default control as user input. This text file needs to be at least 512 characters long as per the requirements of the test. This test is part of the block testing for the main control unit of the large-scale Tetris clone project for ECE 44X senior design. And so let's go ahead and read the output over here. So it says there's a new line that I accidentally typed in there. This is a test of COM1 serial port. It will be used to test the control data signal, which transmits data using the RS-232 protocol at 115.2K baud rate. The Raspberry Pi will need to periodically receive data using this connection. This is how it will read the default controller's user input. This text file needs to be at least 512 characters long as per the requirements of the test. This test is part of the block testing for the main control unit of the large-scale Tetris clone project for ECE 44X senior design where the N is missing. So the reason that the N is missing is because I accidentally typed the new line at the beginning, which meant that it cut off a character from the N. So it was blocking to read 512 bytes, but because I accidentally put the new line in at the beginning, it cut off the N. Okay, moving on. So send the 512 bytes of data across the RS-232 connection at 115.2K baud rate from the Raspberry Pi. So to do this, I'm going to use that data that I prepared earlier, where it's counting from 0 to 63, and each of these groups is 8 bytes long. I was able to basically insert spaces wherever, insert spaces before the number so that it would fill up 8 bytes each time. And because these spaces are printable, it's going to show up on the other console as actually spaces and not hex 20s. So I'm going to go down here, and I'm going to, I gotta switch the keyboard input from my test PC and connect it to the Raspberry Pi. Okay, so I'm going to call sir.write and then as an argument I'm going to put in my data, which I created. And so the second I press enter, this is going to appear on the other screen. So the reason I've got kind of these weird views is because the power cord of one display is attached to the desk on one side of the room, and then the other one's on the other side of the room. So I apologize for having to switch back and forth so much. Let's see. So I'm going to take the keyboard, and I'm going to press enter. And so we see here that it sent 512 bytes, and now I'm going over to my test PC and I am seeing what was sent. So I look in my terminal window and I see that we have, counting from 0 to 63, groups of 8-byte strings essentially. So if I were to count each one, it'd be 1, 2, 3, 4, 5, 6, 7, and then the 0 counts as the 8th byte. So noticing that they're all in even columns, so they all align, all of these groups are 8 bytes. And since there are 64 of them, that's 512 bytes that was successfully sent from the Raspberry Pi to the test PC. This pretty much concludes the test because, let's see. So in order to pass, at least 99% of data received matched what was sent. So in this case, everything that was sent was received, and even my mistake in typing was received, so that just shows that everything's being received that's being transmitted. The communication goes both ways, so I tested transmitting from the Raspberry Pi to the test PC, as well as transmitting from the test PC to the Raspberry Pi, and both times they received 100% of the characters that were sent.